Hello everyone.
My name is M. Krishna Prasad and I am from mechanical background. Today we are going to discuss about a topic called virtual manufacturing concepts. So the base of all manufacturing concepts, all the mechanical concepts, all the manufacturing procedures is what exactly a manufacturing process is. Okay, the manufacturing process is nothing but it is a conversion of raw material to output, or it is a process from raw material to preparing output. It is nothing but a manufacturing process. Now, what exactly this manufacturing process will do in an industry? Okay, so if at all I'm having a industry and I'm having n number of machines, some 4 machines are there, and I'm having 4 workers, and I want to generate some 100 pieces of output. Then what is this? So I need to know how to use these machines continuously or at its best. Then only I'll get the best output. Otherwise, what will happen? I'll run the machine for 4 hours and I will set it idle. I will make it idle for the next 20 hours. And again I will run the next day for 4 hours. So what will be happen here? The machines will sitting idle and we are not using the resources continuously or fully. So we are getting some 100 output. But if at all you are using, if at all we are trying to use the 4 machines continuously, which means if at all we are using the 24/7, which means I want to run one mission for 20 hours in 24 hours, which means per day it should run for 20 hours with having 4 hours of break time. Then what will happen? Previously I will get some 100 output. Now definitely the output will be increased. It will be around 150 or maybe 200. Like if I am considering 4 missions, what will be happen? Previously I will get 400 output. Now it will be like somewhat around 200, or it would around some 1500. So based upon the procedure, based upon the process only, the manufacturing plan was completely depends. So now what exactly this manufacturing depends? Okay, manufacture depends upon. So like I already explained you, I am having a mission. Okay, 4 different missions. The 4 missions will be conventional missions. Now the question is, what is a conventional mission again? So conventional mission is nothing but manual mission. So which means you are going to give speed, feed, whatever it may be on your own. If you want to move your bed from X to negative X or Y to negative Y or Z to negative Z, then you need to rotate the lever, then only it will move. That is nothing but a manual mission. If these are examples for milling mission. If you want to run a lathe mission, manual lathe mission, then you need to on the mission. If you want to increase the speed, then you need to, if it is a belt drive mission, you need to increase the levers, you need to change the gears, and you need to give the feed, manual give feed with the help of tool stock. You need to move the tool stock because according to your design. If it is for a turn application, if it is for grinding application, again same, you need to give on its own. So these are called as conventional missions. Means conventional is nothing but the manual missions. We are going to perform the operations manually is nothing but conventional missions. The advancement for conventional is NCs. Okay, then involvement, innovation for the NC is nothing but CNCs. Okay, but NC is nowhere using here. Now at all everyone is using either conventional or CNC missions. So we'll talk about the CNCs. What exactly the CNC mission is? CNC is nothing but computer numerical control mission, which is directly operated and controlled by a computer. Okay, so if at all I am giving a program, 10 lines of program to the mission, to the CNC mission, then I can run the program. The mission will do the operations which were described in the 10 lines only. Other than that, it won't perform. Even it won't. If at all I started the coolant at some 5th line and I forgot to off it, and I completed the program 10 lines, then what will happen? The machine will perform up to 10 lines and the coolant won't off. Why? Because there is no any command for the coolant to off. Okay, now understand. So the difference between conventional and CNC is, computer numerical missions is, conventional is everything you need to be performed in a manual way. So you need to give its own way, own feed, own speed and own movement also. Whereas in CNC machine, there is no need of giving manually. So all you need to do is, you need to prepare a program, you need to generate a program, and you need to prepare some codings, G codes and M codes, and based upon that codings only, based upon that program only, you can prepare the output. So if at all your object is a complex, or it is a smaller one, it is a normal one, it's a regular one, if at all is having some hollow complex shapes, if at all it is having a 5-axis oriented one, but every operation, every complex object should be prepared in a programmable way. It should be generated by G codes and M codes. Then only you will implement that code to the machine and you can run the program. Without that program, you can't even normally run the CNC machine. Okay, CNC machine completely depend upon the G codes and M codes, the programming language. Okay, so this is the main difference between conventional as well as this CNC machine. So now what exactly the CNC machine will work? CNC machine is nothing but it is also a conventional machine, but the conventional machine is completely automated with the help of sensors, actuators and some other devices, and they are connected to a computer. Okay, and that computer will completely control that program, controller that control the complete CNC machine. Then it only called as a CNC machine. So if I want to run a program, if I want to prepare an object, then I need to generate a code, I need to create a code. Then only that program, that controller will run that program, and based upon running that program, it will move based upon the program we have given, the codes which we have given. With the codes, by reading the codes, the controller will process the signal to the machines or the servo motors. Then only based upon the signal, the motors will move, whether horizontal, linear or rotary, by increasing the speed, depth of cut, everything will be depending upon the depending on the codes only. So this is the main aspect. Now, so what exactly the computer plays a role in CNC machine? This computer completely controls the program. Okay, so if you want to create a program, if you want to create a modify a program, if you want to edit a program, that will be generated by the computer, which will be inscribed in the CNC machine. Okay, the computer which is inscribed in CNC machine is nothing but a controller. Okay, the controller. So you can directly modify a program, or you can edit a program, you can create a new program over there directly by using codes. There will be some panel will be there with some keyboards, key pieces will be there. Directly you can click that and you can prepare a program on the controller directly, and you can run the CNC machine. But that will be a difficult task. If at all you want to perform a program for this pen, okay, so this pen is a cylindrical in shape and it is having some different irregularities will be there. I don't want this one, so I want this one. I want to prepare a program for this one. If at all I go and I directly use the CNC machine and I directly prepare a program, it will be a difficult task for me. Why? Because I don't know exactly how much length is there, how much width is there. I need to check each and every aspect with the vernier calipers, and I need to check everything. So I need to check this diameter, I need to check this taper area, I need to check everything. Then only I will get a perfect designed output. That should be done in the computer. See, first I want to prepare this pen, then all I need is a design. Without the design there will be no proper processing with there. So I need a proper design. First I get the design, then after studying the design, a skilled labor is needed for studying the design. So how much diameter is needed, how much halo is needed, how much tolerance was needed. Why? Because this pen should be entered into this cap, so there should be some tolerance. If at all the diameter is greater than this one, so whether it will be, no, it won't fit. Whether it was smaller than this one, then the given, what will happen? Then it won't fit again, it will be in loose one. If at all it is both are in exact size, what will happen? Then only you can't get this motion. So you need to, if you at all you want to manufacture this one, you need to follow some set of principles, some certain design rules which were given in the design document, like surface finish, fit, tolerance, diameter, clearance and everything. Then only we'll get this desired output. So this is the first step. Okay, we are having the design, we are having everything, then we need to run on the CNC machine. Then what will be, then what is the concept here? Again a problem. So directly running the CNC machine is okay, but not for the complex parts. For complex parts, for a continuously production process, all you need is a designing software. First you need is a designing software or a manufacturing software to run your operations virtually and check whether the operations were running perfectly or not. So okay, let us take an example. I have prepared some program randomly, I have prepared manually program for this one. I have put that application in CNC machine and run the application. Maybe because of the hurry, I just spell wrong, I just wrote a wrong command. What will happen? Automatically either the tool will collect some other workpiece, or it will remove excess material, or it will damage the workpiece or a machine or tool or what it may be, the damage will be there. So for decreasing those type of errors, so there should be a software, and there is a software also for running these type of operations. Okay, that is known as a virtual manufacturing concepts. Those are nothing but, so okay, virtual manufacturing concepts. Those virtual manufacturing concepts should be done on a computer. So That software name is called as a, that concept is called as a computer aided programming manufacturing, CAM. Okay, computer aided manufacturing. So what exactly happens in CAM? Okay, the shortcut is CAM, computer aided manufacturing. If at all I want to prepare this pen, so the base of the CAM is designing again. So first I need to design this pen in a designing software. So I have a design sheet with me with all the errors, tags and everything with me. So I need to design my pen in the design software. So let us take an example. I'm having a Siemens NX. So I can prepare this pen in a Siemens NX software. Directly I prepare the pen. So I'm having a pen with all the given dimensions, surface finish. I have checked everything. Everything is perfect with the design file, drafting file. Okay. Now I want to convert that pen into manufacturing, that design file into manufacturing. I want to run the operation for that. Okay, so again the previous one is a design one, that is called as a CAD, computer aided designing, and I want to convert that design file into manufacturing file, that is called as computer aided manufacturing file. So I'll import that file to manufacturing plot. Okay, manufacturing path I have imported, and first step I need to observe is so I need to perform this operation. On which operation I need to perform this one? Whether it's a turning or a milling. So clearly it's a turning operation. Why? Because it's having a cylindrical length completely. If at all I'm having a cube, block, or it's having a straight face, then I'll go for milling. But in this application, it's a turning application. So I'll choose the turning application. So what will be happen? The turning tools will be present over there. So to generate a turning program. Now by using the computer software, so CAM is a software, it is having all the tools, all the operations, all the procedure. So there will be 3 different steps. Okay, it's not a big task for a CAM. CAM is a small software. All you need to do is you need to give 3 main steps, 3 main approaches or 3 strategies. First one is, all you need to do is create a tool. Okay, so I want to prepare this object, so I definitely need a tool which is ready-madely available in job floor. Why? So let me tell you clearly. So now here I am using a turning tool, okay, with some 50 mm diameter, whatever it may be, but I don't have that diameter tool with me in the job floor. Then what will be happen? My tool won't run, my machine won't run. Why? Because they both should match. Then only whatever we are giving virtually, that should be matched with the job floor applications, like a direct application. Then only this program will run. If at all I am giving 10 diameter here and I don't have the 10 diameter over there, the program won't run, it will be stopped. Okay, if at all I am having both 10 diameter over there and 10 diameter over here, the program will be performed continuously. So this is the main step. So this is how. So I am creating a tool here. So I am creating a tool. So let us take example. If I am having a tool library, so which means I am having some X number of tools which are in the workshop. So I will take that library and I will check in that library and I will prepare according, I will pick some tool, okay, according to the availability of the tools in job floor, and I'll import that tool here. Okay, now first part is tool done. So I have a tool here and the same tool is matching with my production directly workshop, done. And second piece is I am defining this workpiece. So this is what my workpiece is. Okay. This is what my final object is. Okay, I want to create this final object, but the raw material should be, maybe it is having this much of diameter. Okay, maybe it's having greater diameter. That's the raw material. So we need to define the workpiece. That workpiece again. So if you're having a cylinder, okay, cylinder having this diameter, and that is the raw material, and that raw material need to be defined here. Okay, as a workpiece. Out of that raw material, what will be happen with the operations? We are removing the excess material and finally we are preparing this pen, right? So this is the second concept. First concept is again tool preparing. So based upon our tool library which is available in the job floor, that tool need to be imported in this one. First concept. Second concept is based upon the raw material length, we'll prepare the raw material on this one. Okay, so second one is done. And third one is the main one, procedure. So we have imported tool, we have imported workpiece, and now I am having a cylinder like this in virtual. Okay, now I need a procedure to remove this excess material to get this final shape. That it need to be done by using procedure. Okay, and in procedure also directly there will be separate process will be there. This operation is nothing but roughing operation, right? material removing operation, turning operation, roughing operation. There will be three different type of operations: roughing operation, semi-finish operation, finish operations. Why? Because if at all my raw material will be like this, it is having some 10 mm diameter and my pen is having 5 mm diameter, so I need to remove 2.5 mm diameter. So if at all I give directly 2.5 mm, what will be happen? The depth of cut will be more. So because of the greater depth of cut, the tool will be weared or damaged. So I need to give minute. So I need to give 1 mm or 2 mm or 0.5 mm or 5 mm. Then only what will be happen? It will be removed continuously. So for that procedure, so we are using three different approaches: roughing operation, semi-finish, finish. In roughing operation, I will remove the material up to 2 mm. So this is total 10 mm. I will remove up to, so this way I will remove up to 7 mm. So some amount of remove. Okay, first operation is over. And second operation, I am giving semi-finish operation. In semi-finish, what will happen? Only 2 mm part, 2 mm or 3 mm, we need to left. Remaining operation complete part was removed, material was removed. Then I have done with the operation also. And finally I need to select finish operation. And after selecting finish operation, the material was removed completely, and finally we will get this pen visible in the workpiece. Then only the operation was perfect. So we are considering here how many operations, how many processes? 3. First one is roughing operation for removing excess material, greater excess removal. And second one is semi-finish. Semi-finish is for removing almost all the material except 2 mm or 1 mm left. And finally finish operation is for completely removing the excess material. Okay, and finally it will be ready for the output. So that is what the finish operation will be. So now I have done with my virtual environment. So I have given 3 different comments. So again I am telling you, so first we have checked the tool, that is perfect and that is matched with the tool library. Second one is cylinder block, we have created the workpiece here, raw material workpiece created, and that also matching with our existing workpiece raw material. And third one, we are creating procedure, 3 different procedures. First one is roughing operation, second one semi-finish, and third one is finishing operation. So we create 3 different operations, and finally what have we done? My pen is ready. Now I will run the program. So it is running perfectly. Now this in virtually it is running perfectly, but I need to travel that program to CNC machine. This is how. Then what is the step? This is another step, that is called as a post process. The name itself indicating post process. After completion of this process, we need to travel this process to the machine. Okay, so my machine is having, so we need to click that icon. There will be icon is a post process. We need to click that post process. Then what will be happen? So it will ask for a mission list. Okay, so which machine we are having, whether we are having CNC 3-axis, CNC 4-axis or CNC 5-axis, and companies also, Milton, Fano, like different companies will be there, company missions also it will be produced. So which one we need to, so this operation need to be done in the turning operation. So it will be there, turning operations also, mill 2-axis, mill 3-axis, multi-mill, mill 5-axis will be there. So we need to pick mill turn or turning operation. So automatically the lathe will be selected, 2-axis lathe will be selected, and once we select the axis and we will click generate, there will be operation called generate. Generate means creating. So if we click create, what will happen? So we have created the complete cycle. Okay, step by step procedure, created tool, created a workpiece, created operations. So these complete procedure 1 2 3 4 5 complete 5 procedures will be converted to a post process file, which means that file should be readable, that should file for only for the lathe machine, for our desired 2-axis lathe machine. Okay, and one file will be prepared. We need to save that file, and if you want to see what exactly it is, if you try to open it, and once after opening it, there will be like a G codes and M codes only. Okay, complete set of sequence from starting Z90 to Z002 and everything M30 till M30, everything should be written in a format. Okay, all the operations which you have done virtually, that should be performed, that should be in this file. Okay, you have the file, so you need to take the file, you need to copy that file, and you need to travel it, you need to give that control to your CNC machine, and you need to first run the machine without putting any tools or without putting any workpiece over there. You need to run that machine first. Test run, we call it as a test run or trial run. So test run, so everything goes well, there is no any collision, there is nothing, everything goes well perfectly, then your run is perfect. Then what will be happen? Then you need to put the tool, you need to put that workpiece and everything, and you need to run again. So So for the first run, you need to check whether everything is perfect or not after inspecting your workpiece with the design. Once the first one is ready, then you need to start your production. Like how many number of units, if you want to run that operation for 100 units, you can run the program. If at all you want to run the operation for 1000 units, you can perform it. That can be performed later. So that is the main thing. Okay, so this is what the virtual manufacturing concept is. So this I have explained completely for turning. So if at all I am preparing a milling operation, similarly nothing, there is no any exam, there is no any worries. Why? Because directly we need to prepare that body. So I want to prepare a cube. Okay, there is a cube, Rubik's cube is there. I want to prepare that cube in a design first. Okay, in a manufacturing, in a computer software. So completely I prepared a cube with some 10 mm of diameter everywhere. So I need to convert that program file into manufacturing concept. So again, after converting into the manufacturing, we need to pick which machine we are using, whether milling machine, whether 5-axis machine or a multi-mill, we need to pick that. So once we are selecting the milling machine also, we need to same procedure. First one is tool preparation, tool making, object raw material preparation. Third one is procedure. First one we need to prepare the tool. So we need to create a tool and we need to choose the tool which you are having in the tool library outside, which is in the job floor. So we need to fix the tool one. Tool, create the tool. Next one is specifying the job, specifying the workpiece. We call it specifying workpiece. If at all my cube is having some 10 mm of diameter, but the raw material is having 15 mm of length. Okay, so I need to create a 15 mm of length block over there, so that my raw material is also ready, my tool is also ready. Then the third part is machining. Again the machining, three concepts. First one is roughing, semi-finish, finish. First I need to click the semi-finish and I will ask the machine to remove some excess material, and second one is semi-finish, ask the machine to remove the material almost, and third machine is removing the material up to its last extent. Okay, so this is how. Once I am creating that one, then what is the next step, immediate step? So I have all the concepts. Now I need to post process. I need to first run it. So my running is also perfect. Virtually it is performing the operation, even the complex part. If I want to prepare some eagle leg shape, I need to prepare the design first. Same, after completing the design, I need to import it to same what it is, manufacturing concept, CAM. So I convert into CAM, and we are using 5-axis machine. So we are clicking the 5-axis machine, and first one we need to create the tools, second one create the workpiece, third one we need to create the procedure, roughing, semi-finish, finish. Once you are done with the virtual concepts, then we need to post process it. Post process is the concept that will convert your virtual program to mission program or a file that can be run in a CNC machine. So you need to generate that program, and you will get the program, desired program, in a file. And if you open it file, and you will see all the G codes and M codes in a sequential order. You can save that file and you can run the file in a CNC machine, like exactly. So you need to test run it. So you need to test run it perfectly initially. So whether there is any delay or whether there is any errors will be there or not, you need to check that. So once it is free from all the errors, and you need to put your workpiece and you need to put your tools back, and you can run the program. That is what the manufacturing concept is. Okay. So why exactly we are using manufacturing here? So we are using manufacturing for increasing the production rates again. So this manufacturing complete concept. So if at all I want to prepare that type of eagle-like structure manually, it can't possible in conventional. That can be possible only in a CNC. That can be again possible in a by using CAM environment or virtual manufacturing environment. So by using virtual manufacturing environment, we can create any type of object and we can run exactly as per design. So this is what the concept of computer-aided manufacturing is. Okay. With this, I am concluding that computer-aided manufacturing is essential for all the industries which are running continuously, which is having a flexible automation, which is having a normal flexible automation, which is a fixed automation or programmable automation, whatever it may be. So the automation is there. Then if the CNC machine is also there, then the virtual manufacturing should be there. Why? Because without virtual manufacturing, it is difficult to perform a complex part or a part. Even it is easier, even it is possible to perform, but it will take time. So if I want a higher output, if you want a higher repeatability, having higher profitable and having quality of your output, then you need to use this virtual manufacturing concept. That is nothing but CAM. Okay. Thank you.